All right, thanks for tuning in to another chemistry lesson with Mr. M. In this video, I'm going to cover how to solve a stoichiometry problem. So let's get into it. Our example here says, what mass of sulfuric acid H2SO4 is required to react with 1.27 grams of potassium hydroxide, KOH? The products are potassium sulfate and water. So the first thing that we need to do is we need to write out our chemical reaction. So we have sulfuric acid, H2SO4, reacting with potassium hydroxide, which is KOH, and that's going to give us potassium sulfate, which is K2SO4, and water, which is H2O. Once we have our reaction written out, we need to make sure that our reaction is balanced. I'm not going to cover how to balance a reaction in this video, but we do need a 2 in front of the KOH, and we do need a 2 in front of the water. And essentially, what a balanced reaction means is that we have the same amount of atoms on each side of the reaction. Now, once we have a balanced reaction, we can start getting into the math. Now, I use a T-chart method, and with a T-chart method, we always start with the value that we are given in the problem. So, in this case, we are given 1.27 grams of potassium hydroxide. So we need to start with that. So we're going to start on the left here, 1.27 grams of KOH, and then we are going to start our T-chart. Now, with the T-chart method, what we are trying to accomplish is we are trying to basically cancel out our units until we get to what the question is asking us. So if we have grams of KOH on top of the T-chart, the only way to cancel out this unit is to make sure that it's on the bottom. So we're going to put grams of KOH down here. Now, what can we do that's going to give us a conversion, right? So maybe in your class you've heard of a grams to moles conversion. So we can go from grams of KOH to moles of KOH, all right? And so for every 1 mole of potassium hydroxide, we can find its molar mass. And this is where you are going to the periodic table to figure that out. So you're going to add up the atomic mass of potassium, oxygen, and hydrogen. So if you look at the periodic table, potassium has a molar mass of 39.1. Oxygen has a molar mass of 16. Hydrogen has a molar mass of 1. So we're going to add up all of those values from the periodic table, and we get 56.1 grams of KOH is equal to 1 mole of KOH. All right, and then we continue that process. So if I have moles of KOH on top, the only way to get rid of it is to put it on the bottom. So we're going to put moles of KOH here. All right. So what's our unit conversion factor here on this section of the T-chart? Well, if you've ever heard a mole-to-mole ratio, the mole-to-mole ratio is what we are doing at this point. So this is where we need to look at our balanced chemical equation, all right? We know we are trying to find the mass of sulfuric acid. So we are trying to determine what is the mole-to-mole ratio between moles of KOH and moles of our sulfuric acid, H2SO4. And this is where you're looking at the coefficient in front of your balanced equation. So for every 2 moles of KOH, we react with 1 mole of the sulfuric acid. So for every 2 moles of KOH, we have 1 mole of H2SO4. All right, we're finally getting to the end here, right? So we have moles of H2SO4 on top. We need to have moles of H2SO4 on the bottom. And here's where we can go back to our mole to molar mass ratio. For every 1 mole of H2SO4, I can add up how many grams that is looking at our periodic table. It's the same thing that we did when we did this. So you're going to look at the periodic table. Hydrogen has a molar mass of 1, and we have 2 of those. Sulfur has a molar mass of 32.06. Oxygen has a molar mass of 16, but we have 4 of those. So you're going to add up all of those from the periodic table, and we should end up with 98 98.06 grams of H2SO4 for every 1 mole of H2SO4, okay? And so here's the beauty of the T-chart. I can now cancel out all my units. Grams of KOH gets canceled out. Moles of KOH gets canceled out. Moles of H2SO4 gets canceled out. And so what am I left with? I'm left with grams of H2SO4, which is what the question was asking, right? What mass of H2SO4 is required to react? So now that all of the other units have canceled out, it just becomes a math problem. And what you're gonna do is you're gonna multiply all of the values that are on the top, and you're gonna divide it by the product of everything that's on the denominator, all right? So we're gonna do 1.27 times, we should technically do times 1 times 98.06, but I don't like showing the ones because we know that they really don't have an effect here, okay? And we are going to divide that by the product of everything in the denominator. So in this case, it'll be 56.1 times 2, all right? So when we go ahead and do the math, 1.27 times 98.06 gives us 124.5, and 56.1 times 2 gives us 112.2. And then we can, if you wanted to skip that step, you could have done it all in the calculator at one point. But if we go ahead and do this, the 124.5 divided by 112.2, we get an answer of 1.11 grams of H2SO4. And that is our final answer. So I hope this video has helped you in solving your own stoichiometry problem. And as always, thanks for tuning in.